Welcome to True Projects. In this video, we are going to explain about cyber attack detection method based on NLP and Ensemble learning approach. Introduction. The project addresses the issue of SQL injection, a typical cyber attack on online applications that can result in the theft of sensitive data. The project proposes a detection method that employs natural language processing (NLP) and the Ensemble learning algorithm to generate feature patterns, extract features, transform text into numerical representation, and train a random forest classifier to more accurately classify SQL injection payloads. The project also emphasizes the shortcomings of existing methods for detecting SQL injection, as well as the overfitting and underfitting issues that can arise when employing machine learning models. Objective. The primary goal of this project is to provide an effective SQL injection detection approach that can improve detection accuracy, detection rate, and reduce false positive and false negative rates. The suggested method employs natural language processing (NLP) and the Ensemble learning algorithm to construct feature patterns, extract features, convert text to numerical representations, and train a random forest classifier to more accurately classify SQL injection payloads. The project's goal is to provide an effective solution for detecting SQL injection. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDE with 3.7 version. Algorithms used. To implement this project, we have used the two algorithms. The first one is natural language processing. NLP is a subfield of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. In this project, NLP techniques are applied to analyze the input data, queries entered by users into web applications. By using regular expressions, the NLP module checks whether the input data contains characters as expected or if it deviates from the intended format. For instance, it identifies suspicious characters like or and equal to, which could be indicative of SQL injection attacks. By detecting abnormal patterns in the input data, the NLP module helps prevent potential SQL injection vulnerabilities. And the second algorithm used is Ensemble learning, random forest algorithm. Ensemble learning is a machine learning technique that combines multiple individual models to create a more robust and accurate prediction model. In this project, random forest algorithm is employed as the Ensemble learning approach. Random forest builds multiple decision trees, each trained on a different subset of data and using a random selection of features. By aggregating the predictions from each tree, the algorithm produces a final consensus prediction. Ensemble learning with random forest enhances the prediction accuracy and reduces overfitting, making it an effective choice for identifying SQL injection attacks in the project. Methodology. To implement this project, we have designed the following modules. The first module is Upload SQL Payload Dataset. In this module, the system allows the users to upload a dataset containing SQL payloads. The dataset consists of various SQL queries, some of which may be legitimate and others may contain SQL injection attack payload. The dataset serves as the basic for training the Ensemble random forest model and evaluating its performance. Second module is Pre-processing and Count Vector BWO. Before feeding the dataset to Ensemble random forest model, pre-processing is performed to clean and prepare the data for analysis. This may involve removing unnecessary characters, handling missing values, and tokenizing the text. Next, the bag of words BOW technique is applied to convert the SQL queries into numerical feature vectors. BOW represents each query as a vector containing the frequency of each word present in the query. This vectorization allows machine learning algorithms to process the textual data. Third module is Run Propose Ensemble Random Forest. In this module, the Ensemble Random Forest algorithm is implemented to create a robust machine learning model. Ensemble learning combines multiple individual models to improve prediction accuracy and reduce overfitting. The algorithm takes the pre-processed and vectorized SQL payload dataset, has input and trains the model on this data. The trained model will be used to predict whether a given SQL query is a normal query or contains an SQL injection attack. Fourth module is existing algorithms. In this module, the system may also include the evaluation of other existing algorithms for comparison purpose. Commonly used machine learning algorithms are decision tree, support vector machine, navy Bayes, may be trained and evaluated alongside the proposed ensemble random forest model to determine the effectiveness of the approach. Fifth module is performance graph. The performance of the ensemble random forest model and the existing algorithms are visualized using performance graph. Metrics such as accuracy, precision, recall, F1 score are plotted to assess the model's effectiveness in detecting SQL injection attacks. This allows for easy comparison and selection of the best performing algorithm for the specific application. Sixth module is predict attack from test data. After training the ensemble random forest model, it is ready to predict SQL injection attacks on new unseen test data. This module allows users to input new SQL queries or datasets containing unseen queries. The model will process these queries and classify them as normal or containing an SQL injection attack based on the patterns it learned during training. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. We have used SQL injection dataset to train random forest. In the dataset folder, we have dataset. In above screen, first row contains dataset column names and the remaining rows contain query and label as normal or SQL injection. And we can see each query is associated with one label as normal or SQL injected. After training random forest with above dataset, we will use the test query. So this is the test query. In above test query, we don't have any label values and this query will be evaluated by training model and then predict label as normal or SQL injected. This is the main code file. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. A graphical user interface will pop up. So this is the graphical user interface. We have created this GUI by using Tkinter library in Python. Using this GUI, we will interact with the project. Click on upload SQL payload dataset to upload the dataset. So this is the dataset. Open. We can see all dataset queries loaded. And this is the graph. On x-axis, we have normal and SQL injected and y-axis represents number of queries. Now close the graph. Click on pre-processing and count vector BOW to convert dataset into numeric vector. In above screen, first row contains all queries word and remaining rows contain contains frequency of that word. And if word does not appear in query, then 0 is written. Now numeric vector is ready and now click on run propose ensemble random forest to train random forest with above data and then calculate accuracy. So after training random forest, we will get the accuracy, precision, recall and F1 score of random forest. Now click on run existing algorithms to run existing algorithms. In above screen with existing SVM, KNN, decision tree and navy Bayes, we got either 50 or 60% accuracy. Now click on performance graph to get the graph. So here we can see x-axis represents the algorithm name, that is we have different algorithms like decision tree, KNN, navy Bayes, random forest, SVM. And y-axis represents the accuracy, F-score, precision, recall values. So from this graph, we can say that random forest is having better performance. close the graph. Now click on predict attack from test data. Upload the test query, open it. So here we can see that the query is predicted as SQL injected query, and this query is predicted as SQL injected query. This query is predicted as normal query. And the final conclusion of the project is, the project addresses the vulnerability of web applications to SQL injection attacks. The system can identify odd patterns in user input using NLP and regular expressions, reducing the possibility of fraudulent queries accessing the database. Count vectorization turns query word into numeric vectors, allowing the Ensemble random forest algorithm to generate a viable prediction model. The system obtains good prediction accuracy by training on a dataset using SQL injected questions. The approach ensures effective SQL injection attack detection and prevention, enhancing the security of web applications and databases against potential cyber threats.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.